Okay, we're going to work problem 35 on page 105. And, well, here it is. It says, let's see, let me refocus this. It says, figure 4.35 represents the total acceleration of a particle moving clockwise in a circle of radius 2.5 meters at a certain instant of time. At this instant, find A, the radial acceleration, B, the speed of the particle, and C, its tangential acceleration. So here's, I've set it up, like here's what's given. So here's your acceleration, and it has a total magnitude of 15 meters per second squared. And we want to know what's the radial component of that acceleration. So remember that radial, we want to know how much of the acceleration is pointed in the towards the center of that circle. So what we're going to do, and I'm just going to do it on this picture of what's given, it's going to get, I'm going to project this on here. So if here's our acceleration, here's the component of the acceleration that's pointed towards the center. And then here's the component of the acceleration that is tangential to the path. That's our tangential acceleration. So this right here is the radial component of the acceleration. And so this is the adjacent, if this is 30 degrees right here, then this is the adjacent leg of the right triangle formed by the radial component. The tangential component is here. So the cosine of 30 degrees is equal to the adjacent over the hypotenuse. And so now I can solve for the radial. The radial acceleration will be equal to the overall acceleration times the cosine of 30 degrees. So the radial acceleration will be 15 meters per second squared times the cosine of 30 degrees. So when I plug that in, make sure your calculator's in degrees. 15 times the cosine of 30. And I get 12.99, which I'm going to round off to be 13.0, three significant figures, meters per second squared. There's my answer for part A. Now part B, I want to know what is the velocity, or what's the speed, really, of this. And so we know that the centripetal acceleration, the magnitude of it, is equal to v squared over r. So v is equal to the square root of r times the radial acceleration. And so now I'm going to plug in my values. This is 2.50 meters. And we calculated this to be 13.0 meters per second squared, or you could have left it as 12.99. That's fine. And look, meter squared per second squared, when you take the square root, you get meters per second. So always check the units when you do your calculation to make sure you're getting that right. And so v is equal to, well, let's see, the square root of 2.5 times 13, and that should be equal to 5.70 meters per second. So that's how fast I'm going. And then part C, we want to know what is the tangential acceleration. Well, I can look up here and I can see that, okay, it's the opposite leg of this right triangle created by the radial, and the tangential acceleration adds up to my overall acceleration. So the sine of 30 degrees is equal to the opposite over the hypotenuse. So the tangential acceleration will be equal to A sine 30 degrees. So the tangential acceleration is the given 15 meters per second squared times the sine of 30, and don't need a calculator for that. This acceleration will be the tangential acceleration is 7.5 meters per second every second. The big idea here is this. If you know the overall acceleration in some kind of curvilinear situation, the radial and tangential accelerations will add up to that overall acceleration, and they will form a right triangle. And you can use the mathematics of right triangles to solve for those, the legs of it. Okay? And of course, the centripetal acceleration equals v squared over r. Any questions? That is all.